Hello friends, welcome back to our channel. So in today's session, we'll see one more concept in operating system, that is allocation of frames of a physical memory. So we know that the CPU will be executing only the process which is available in the primary memory. So that whatever the process available in the logical memory will be divided into pages, and the physical memory will be divided into frames, so that the process will be loaded. That means the pages will be loaded into the frames of the physical memory. Now, how the allocation will be done? So how many frames will be allocated to each process? So that is the concept, right? So without delay, let us start the allocation of frames. See, so before going to the techniques, so let us know what is the advantage of allocating the frames in an optimized way, okay, in an efficient manner. So obviously, optimized allocation results, the first one, okay, no fragmentation, okay, minimal fragmentation. The wastage of memory will be minimal. Similarly, it reduces the page faults. So we know page fault means if the CPU, whatever, if the page which needs by the CPU is not available in the main memory, then that is called as a page fault. Immediately, the CPU will be loading the page from secondary memory to the primary memory by swapping in and swap out operations. Okay, so the minimal page faults, it reduces the page fault, obviously. If there is minimal fragmentation and reducing of page fault, automatically the efficiency will be more, okay, efficient usage of memory. So obviously there will be a minimal, that means a wastage of memory will be reduced, and the maximum number of pages will be loaded into the frames, so there will be efficient usage of memory, right? So if you allocate the frames, right, to the processes, then these are the advantages. Now what are the different techniques, okay, what are the different approaches to allocate the frames? So the allocation can be done in four ways. One is equal allocation. So if there are multiple number of processes, equal number of frames will be allocated for each and every process here. And the second one, proportional allocation. So depends upon the size of a process and the requirement of a process, the frames will be allocated. Next, priority allocation, not primary, priority allocation. Okay, based upon the priority of a process. So we have seen that some process will be having the highest priority to complete its execution. So in such case, based upon the priority, the number of frames will be allocated. And the next one, global and local replacement allocation. These are two different types. Okay, so these are the different allocation techniques. These many ways we can allocate the frames to the processes. Now we will see one by one: equal, proportional, priority, and global and local replacement allocation techniques. First, let us move on with the first technique, that is a equal allocation. This is a very simple. Okay, it's a very simple. So the first one is a equal allocation. So equal number of frames will be allocated to each process. For example, process, we are having some process P1 and process P2, and number of frames is equal to 30. Number of frames equal to 30. So here equal number of frames will be allocated to each process. So how many frames will be allocated to P1 and P2? So this is for just simplifying the explanation and taking only two processes. So it may be having a more number of processes. Okay, so two processes and number of frames in the primary memory, let us take it as a 30. So this is a equal number. So 30 divided by 2, which gives 15 frames. So simply P1 will be, P1 will be allocated to 15 frames. 15 frames will be allocated to P1, and similarly P2 will be allocated with the 15 frames. 15 frames. Okay. So for example, so this is okay. 15 frames given to P1 and 15 frames given to P2. So if the same thing happens with two more processes, let it be 4 processes are there and number of frames are 30. Now 30 divided by 4, okay, so which gives 7 frames. Okay, so P1 will be giving a 7 frames, so P2 will be giving a 7 frames, so P3 7 frames, and P4 7 frames. Okay, then 7 plus 7 plus 7 plus 7, total 28 frames. But how many frames we are having? 30 frames. So addition to that, 2 frames are unallocated. Okay, so we can't divide a frame and share this frame to two more processes, multiple processes. So we have to give the equal number of frames, and the remaining frames can be unallocated. So which we can call it as free frame buffer pool. Free frame buffer pool. Okay, so those frames will be kept there. And see, this is for a future purpose. This will be for a future purpose. So like that, the equal allocation will be done. Okay, equal allocation will be done. Now, the second category is a proportional. Proportional allocation. So in this proportional allocation, the frames will be allocated based upon the size. So frames will be allocated based on size. Okay, so why? Because here if the P1 is having only 3 pages, P2 is having only 2 pages, so this is a pages example, and P3 we are having some 8 pages, it is having some 7 pages, right? So 3 pages will be loaded into 3 frames. 3 pages will be loaded into 3 frames. But here the 4 frames are wasted. Okay, no page will be loaded into that 4 frames. And in this case, 5 frames are being empty. And here, 1 page should be waited until it completes one process. I mean, 1 page completes its execution of process P3. Okay, beyond the frames, right? So in such case, you can see some portion, some wastage of memory will be there. Okay, some wastage of memory. So in this case of 4 frames, and this case of 5 frames is wasted. right? So in order to avoid that, based upon the size of the process, we can allocate the frames. So based upon the size, frames will be allocated. For example, if you take the same thing, so the number of frames are 30 and P1 size is some 5 KB, P2 size is some 10 KB. Okay, then the frames of a process will be calculated as the size of the frame divided by capital S, sum of all the sizes, okay, into number of frames. So this is the formula, just remember this to calculate the number of frames which can be allocated in this proportional allocation. Okay, see, for example, in this case you can see, so what is the size of P1? Yes, so frame 1, F1 means total number of frames that have been allocated for process 1. So is equal to size of frame, that is a 5 divided by sum. Sum means 5 plus 10. Okay, and into what is the number of frames? 30. So we can write it like this: 5 divided by 15 into 30. So is equal to 10 frames. See, previously the same P1 we are allocating some 15 frames, but here 10 frames will be allocated here. Next, similarly F2, that means number of frames allocated to the process P2. So this is size, it's a 10 divided by sum 5 plus 10 into the number of frames 30. So which is 10 by 15 into 2, which becomes 15 frames. Sorry, 30, so 20 frames. 20 frames. So depends upon the size of the process. Here 20 frames have been allocated, and for P1 10 frames have been allocated. You can observe here. So there will be less memory wastage here. Less memory wastage. Okay. So when compared to the first approach, equal allocation, this will be the efficient proportional allocation. Okay. Next, the next one is a priority allocation. So coming to the priority allocation, as we have said that so we know that if any process with a high priority comes to the CPU, first it will allocate the CPU, I mean it will complete its execution for that particular process. That means based upon the priority, the process will be allocated. So here also based upon the priority, okay, based on priority, more number of frames will be allocated. So highest priority process, if there is any highest priority process, then more number of frames will be allocated there. Okay, that's the only thing. There will be no formula. So the complete frame allocation will depends upon the priority of that process. And the next one is a global replacement allocation and local replacement allocation. It's a very simple concept here also, right? For example, in previous case we have taken two processes. Okay, so for example, let us take the memory. Let us take the memory in both the cases. So for example, this is for process P1 and this is for process P2, and similarly here also this is for process P1 and this is for process P2. Let us assume, okay, let us assume. Now in this case we know that if the CPU requires any page which is not available in this particular memory, so this is a main memory, okay, this is a main memory. This is also a main memory. So for example, page 1, page 2, page 3, page 4, okay. So here also let us take here also let us take page 1, page 2, page 3, page 4, right. So for example, P1 is having 5 pages. Here also P1 is having 5 pages, right. Now you can observe P1, I mean number of frames allocated for P1 is a 4 frames. So obviously 4 pages have been already allocated here. So if the CPU requires the page 5, okay, if CPU wants to execute the page 5, it was requesting for page 5, then it will check whether it is available or not here. Otherwise, so one should be swapped out and the page 5 should be swapped in. In this case, in the global replacement allocation, one process, okay, the one process can allocate its page in the free space of another process. So here you can see P2, for example, P2 already the 3 pages has been fixed, okay. So these 3 pages has been fixed. So this is empty and here also this is empty and this is empty. So if it is a global replacement allocation, if it is a global replacement allocation, the page of P1 can be loaded into the empty frame of another process. So it can utilize the empty frames of any process in the main memory. Okay, the frames allocated for the any process in the main memory. So P1 can utilize the space of P2, or if requires, P2 can utilize the empty space of P1. So this is called a global replacement. So one process page can be loaded anywhere in the main memory. So it can utilize the memory space of another process. But here that cannot be done. So local replacement allocation. So P1, the pages which are related to P1, process P1 should be loaded into only the frames which are being allocated for P1. So here P1 process can't be allocated in the process P2. Okay, the frames allocated in P2. So this is called a local replacement allocation. So P1, so here what happens? One page should be swapped out. That means one page should be removed and moved from main memory to the secondary memory, so that one frame will be empty. In that empty frame only the page 5 can be loaded. So page 5 can't be loaded in this location, in the empty frame of P2. But here the page 1, the page 5 can be loaded in this particular empty page, empty frame. So that is the difference between the global replacement and the local replacement allocation. Right? So hope you understood. And the 3 points we have to remember in this particular allocation of frames, it is the minimum number of frames, a minimum number of frames should be allocated to each process, should be allocated. So we should not avoid the process without allocating the frames. We have to allocate a minimum number of frames for each and every process. And the second one, the total number of frames, total number of allocated frames for all processes, should not be more than total number of frames in primary memory. This is one more important. So whatever the frames we are allocating to the processes, that should not be more than the available frames. Okay, so previously we have seen total number of frames are 30. Among 30 only the 10 frames have been allocated to P1 and some 20 frames have been allocated to P2. Okay, so in the proportional allocation technique, right? And coming to the equal allocation technique also, so 15 frames are allocated to P1 and 15 frames are allocated to P2, where total number of frames becomes 30, which are equal to the available frames of main memory, that means a primary memory. And also the unallocated frames. So this also we have discussed. Unallocated frames should be in, what is that, free frame buffer pool for future use. Free frame buffer pool for future use. So these are the points we have to remember while allocating frames to the pages or a process. Okay, minimum number of frames should be allocated, and the total number of allocated frames for all the process not be should not be more than total number of frames in the primary memory, and unallocated frames should be in a free frame buffer pool for the future purpose. Okay, so hope you understood the main purpose of allocating the frames. Means if you allocate the, if the allocation of frames is optimized, then automatically there will be less fragmentation, and also it reduces the page faults, which can improve the efficiency of using the memory, the fast loading of pages to the CPU. Okay, execution of CPU, right? So I'll stop here, and hope you understood this one. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.